Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to talk about something called quadratic inequalities, which sort of sounds like something we've done before, but to solve quadratic inequalities, it's definitely a little bit harder than some of the other inequalities we've seen this year. So to start off, I just kind of want to motivate it with this problem. So I want you to think about an equation of a quadratic that is always greater than 0, like y equals 0, and one which is always less than 0. There's lots of them here, but basically, if we were to take a picture, right, we just want something like this, like a quadratic that's always bigger than, this is my 0 line right here, this is my y equals 0, and then we want something like this, where the quadratic is always below 0, right? And so you can just use function transformations or something. You can just do x squared plus 1, right, would be a quadratic that's always greater than 0, and negative x squared minus 1. And so what we're really going to do today is we're going to have problems like stuff like x squared plus 1 less than 0 or something. And you have to think okay, well, this quadratic is always less than 0. And so, this quadratic is always greater than 0. So what x's would make it less than 0? Well, nothing, right? And we would answer that with no real numbers. There are imaginary numbers that do it, but we could answer it with no real numbers too. Then you could take something like negative x squared, minus 1, when is that less than 0? And, just based on this picture right here, you can see that this quadratic, right, is always less than 0. So for all real numbers, this is true. And so the idea of these quadratic inequalities is if you can do a quick sketch like this, and then use the picture to kind of help you figure out the answer. So, when you look at this, right, we can see that's all positive stuff up here. So no real number would ever get me less than 0. Whereas this one, all real numbers would make me less than 0. So the idea of this, again, is just, I kind of cut off the top of this, sorry. So you find the roots. The roots are going to be important. And then you can make a very rough sketch, and I'll show you what I mean by that. And then use the picture to help answer that inequality, okay? So this one, if we were finding the roots, okay, we can just factor it. So we can do x minus 1 times x minus 1, right, is how that thing would factor. And so the roots are really just 1. It's just a repeated root, okay? So we have root over, these are by 1s, so we have a root right here at 1. And then, so that's just step 1, let's say, is done. Then I want you to make a very rough sketch based on the sign of a, okay? A being the, scale factor in here. And basically, it's just a positive quadratic. So we know that this thing opens up. So we know it's something like that. I don't care right now how perfect it is. I mean, really, as long as you know that it just comes in, touches there, and keeps going up. It could be really skinny, like this one, something like that. Any of those are fine, but you just know, I'm just going to do just one. So you just know it looks something like an open up quadratic, right? And then that should be enough to help answer the problem. So this quadratic inequality says, when is this thing that we just drew, when is it greater than 0? And it's almost always greater than 0. The only time it's not greater than 0 is when it equals 0, right? 0 is not greater than 0. So you would say that the final answer on this problem is x needs to be either less than 1, or x needs to be greater than 1, right? less than 1 is like going to be all this part over here. That's greater than 0. And then, this is like the one like bad point because it equals 0 at that point. But then as soon as you move past 1 to the right, you also are greater than 0. So these problems, you always answer them, like there's only one variable here. So we only ever answer them with one variable. It's not like a two-dimensional problem or something. We're using a two-dimensional graph to help us answer it, but the idea is to answer it with one-dimensional answer like this, just based off of the 2D picture. And that's it. So you basically find the roots. The roots are going to be important if we're like relating it to 0, right? And then we make a rough sketch just based on whether it really opens up or down based on the sign of this. And then we should be able to look at the picture and answer it. So in this one, besides that value at 1, where it equals 0, not being greater than 0, it's greater than 0 everywhere else. So we can just say less than 1 or bigger than 1. You honestly could also answer this problem as all real numbers but 1. That's a perfectly fine answer also, because everything but 1 works in this problem. So I just want to do another one, different kind of answer for this one. So find the roots. So x squared minus 4x less than 0, less than or equal to 0. I just want to find the roots of this thing. So this is a nice one for factoring. I'm just going to take out an x, right? The roots would be 0 and 4. Those are my roots. So then rough sketch, you just plot 0 and you plot 4. And then you know that this is a quadratic that opens up. So you can just do something like this. It's just like, I don't really care how low that thing goes, like where the vertex is. I just need to know that it opens up. And that you get, again, just by this positive 1 in front. So then I just look at this picture, and I just answer when is it less than or equal to 0. So, my 0 is right here. So less than or equal to it right here are the roots, right? That's going to be part of the answer. And then this stuff down here is less than, or equal to 0, right? So to describe that region, right, we need to describe all these different x values in here that give me the graph down here, okay? So this would be like a and problem. You would say 0 is less than or equal to x, which is less than or equal to 4. And that'd be it. So, 0 and 4, the 2 times it equals 0. And then everything in between, if you plug in like 2, let's see, 4 minus 8, right? 4 minus 8 is less than or equal to 0. If you plug in, though, like 4.1, I guarantee you it's not going to be less than or equal to 0. Maybe let's just do it. So just to kind of see that that really is the right region, let's check that like 4.1 doesn't work because it's not in the correct region. So 4.1 squared minus 4 times 4.1. This equals, I'm going to use a calculator. 0.41 is what that equals. And 0.41 is not less than or equal to 0. So, that's good. We don't want 4.1 in there because as soon as you get to the right of 4, you're getting into this chunk, right? And that chunk is positive. And you want to be less than or equal to 0. So, this is just kind of important, concept question. So how many solution cases are there for quadratic inequalities? So we've seen a few already. There's actually 5, which is kind of weird. We've seen 4 so far. So we saw no real solution on the first slide. And then we saw all real numbers on the second, okay? And those are basically, these two would be the cases where the quadratic sits either fully above or fully below. Don't think that this one is always no real or something. You can get both of these for both of these. So it just depends on what the inequality is. But we've seen those. That's like these cases where it doesn't cross the x-axis anywhere. Then you can have like an and problem or an or problem. And we saw both of those. Here's an and one, and here is an or one, right? So these cases are like when you have quadratics actually cross, and you can have like maybe a less than case, so like an and one down here, or you could have it shoot off in two different directions. That would be like an or. Then there is one more case. So you can actually have a single point, which is kind of weird. And I would recommend you like pause and think about it. And I'm going to show you it right here, but the idea is like this. So if you have a quadratic, say x squared less than or equals 0, right? X squared looks something like that. And it comes down and it touches 0, right? This quadratic, it being less than or equals 0, is only true when x equals 0, right? Because most of the time, it's above the 0 line. Most of the time, it's just up here. X equals 0 is the only point that makes this inequality true. So that's kind of weird, but there's actually 5 cases for quadratic inequalities. All right, so I just want you to think about just another example of a quadratic inequality that has a solution which is an or, because the one we did before is kind of weird, and I just want you to see another one. So I would again recommend you kind of pause and ponder and think about an answer to this question, and I'm going to put one down here right now. So let's take just a graph like this, and let's say this root is -2 and this root is 2. So that quadratic could be something like x plus 2, x minus 2, right? And you really could just put any number you want in front. You could put it just can't be a negative, it just needs to be a positive. Let's say 16 for no good reason. So 16 will just change how like steep and squished this thing is. It basically it changes the vertical stretch, right? So this quadratic could represent this, and we want this quadratic to be have an or solution, right? So you want a problem that like is split in 2 chunks. Like the solution needs to represent, let's say, those 2 chunks. So we want answer like this. We want, when is this quadratic greater than or equal 0, right? And that would be a quadratic inequality where you'd have to answer it being bigger than 2 or less than -2. The answer to this thing would be x bigger than 2 or x, bigger than or equal to 2 or x is less than or equal to -2. So that would be the answer. But really the question, asks you to write and solve, I guess, the problem. But the idea is, again, just it's split into 2 chunks. So you have to use the word or to connect them.